Hello, my name is Miroslav Klavansky. I'm Principal Field Solution Architect for Pure Storage, focused on analytics and AI. And today I'd like to talk and demonstrate how you can use Pure Storage FlashBlade to support data export from Vertica and use it for hosting external tables for Vertica and Eon mode or even enterprise mode. So with that, let me introduce a little bit about my environment. For this demo, what I have is a small cluster with 4 nodes. Each of those nodes has about 512 gigs of memory and 48 cores and an SSD for the boot drive and depot. These are actually pretty old machines, so the CPUs are not that powerful and the SSDs are not really that fast, but that's the environment I'll be demonstrating. I also have a small Pure Storage FlashBlade. Now, this FlashBlade is pretty much the smallest FlashBlade we offer. It has 7 of the 17 terabyte blades, but it's still plenty fast to do a lot of work from the Vertica perspective. So this is the overall environment. And in addition to that, we have the terminal, which is where I'll be doing most of our work. This example was built up to augment and supplement the Vmart example database that every Vertica instance ships with. We will basically be taking the Vmart data that is generated inside this example and loaded into the database, and using that data for our demonstration around exporting data and also using external tables. Okay. As I mentioned, we're using an extended Vmart database example. So here I am in my directory that holds the Vmart code. It is at opt vertica examples vmart_schema. And I've added a bunch of code to that directory to demonstrate the stuff that I want to demonstrate. Database that I'll be working with is a 100 gigabyte database. And if I take a look at it, the generated data was in this directory, and it holds about 104 gigabytes worth of generated raw files. That data has been imported into Vertica, and the Vertica database that it's been imported into is storing the data in ROS format. If I take a look at that directory, it's held inside of this path, this S3 path. And that data is using, call it 39 gigabytes of data. So with ROS compression, even with the catalog and other metadata files, it has shrunk from 104 gigs to about 39 gigs worth of data. When we export the data, we'll take a look at the exported size. So this is what we'll be working with. To start using this additional code in the example, I first needed to generate the Vmart data like I normally would, and then load it into the Vertica database. Once it's loaded into that database, then I can start doing things like exporting it into Parquet format and creating external tables based on that exported data and testing with those tables. So that's pretty much what I'll be demonstrating today. The export code essentially looks like this. Okay. The key here is that when you call this SQL code, you pass in a variable called ext_prefix. And with that, you point it at the destination where you want that exported data to go. If you want it on NFS, you specify a mount point where the FlashBlade is going to be mounted in your NFS file system tree. And if you want it in S3, you specify a URI with S3:/ that provides the prefix where those exported objects will live. Okay, so I'm going to be exporting it onto S3. So To do that, I specified S3 colon slash slash Vmart dash exported, which is the name of my bucket, slash demo. And during this demo, the data is going to go into that path, and then the name of the SQL code that I was just showing you. And when you kick it off, you see that a bunch of the small tables were already exported right away. There is a fairly large fact table with about 1.3 billion rows in it in this database that's going to take longer to export, about 5 minutes. So while that is running, why don't we go back and take a look at the FlashBlade? So right now, Vertica is sort of crunching through all the data, trying to figure out how to structure the exports, maybe compressing some of the data in memory. Honestly, I don't know exactly what it's doing in the preparation step. I just know from past experience, it's going to take about, 3-4 minutes to fully export that very large table. If I go to my management console and take a look at the activity tab under query monitoring, I see that my export to Parquet query is running. So it's going to be running for a little while. I'll just keep looking at it, and frankly, I'm just going to fast forward this part. Okay, so the largest table has already been exported. If I take a look at my dashboard and kind of drill into the performance, on the 5-minute tab, I can zoom in. So all of this activity was essentially write activity to the FlashBlade. The peak throughput was somewhere around here, call it like 1.4 gigabytes per second. And this is just like pushing out the table data after Vertica has already processed it and figured out how to write it out in ZSTD compressed format with Parquet. Right. So if I go back to my terminal window, I see everything is done and it's been exported. Now, if I take a look at the location where we exported it, we see that after it's been ZSTD compressed in Parquet format, it takes up about, call it 23 gigabytes of storage. So again, about 104 gigabytes raw as text, about 39 gigabytes in ROS format with the catalogs, and about 23 gigabytes in compressed Parquet. So, there are kind of pluses and minuses for each of these formats, of course, and, just putting the relative sizes in perspective. But the main thing that I wanted to just emphasize is it's very easy and straightforward to take data that's in your Vertica database and export it to FlashBlade in either S3 or NFS format. I used S3 in this demo. It would have been just as easy to supply a path to a mounted NFS share from my FlashBlade. Right? Okay, so the next thing that I'd like to demonstrate is just what it looks like to create external tables from this exported data. For that, we have a different script. And if we take a look at this Vmart define, let's say, the NFS schema.sql, what we'll see is you just pass on a prefix where the exported data lives. And instead of creating the tables, we are creating external tables, and we are creating them as copy from the input location Parquet style, right? So that's pretty much it. We create the external table, and then we do it as copy from Parquet. And Vertica figures out the rest, and this can create these external tables. If we look at the S3 version, it looks identical. The only real difference is the NFS tables start with S3, or NFS tables start with NFS. The S3 tables start with S3. If I take a look at what's already inside my database, essentially for each one of these tables, there's a regular version, which is what got originally loaded into the Vertica database. And then there's a NFS version of the table and an S3 version of the table. And they are in the same schemas as the original table. So that's pretty much what's loaded in the database. So the final bit of code that I just want to show is some example code for running queries against the different types of formats, whether that is external tables in NFS, S3, or native ROS format tables stored in the database. To do that, I created this Vmart pquery command. It's actually derived from the example of the execute query in parallel code, but improved to provide a bunch of flexibility. If you take a look at that code, and let's go and take a look at this. What we'll see is, there's some definitions. There's essentially some helper functions for catching control Cs, printing usage messages, parsing arguments, closing all the sessions. But all the action really happens inside of this loop. Essentially, what we're doing is generating a random number to select one of the 9 queries that Vmart ships with to run, generating a new session up to the number of sessions you specified, and running one of the random queries in the session on one of the hosts in the cluster. And it essentially does this for some specified duration period of time, right? So if I run the command with the -h flag to show the usage, we can see that it's there, and how to use it. And, the next step is really just to kind of show it in action. Now, running this for any period of time will take some time. I'm going to kick these off and just keep recording and then speed up the recording so you can see what it looks like. So the first format that I'm going to use is just the native ROS format. Now, if I kick this off and then go back to my FlashBlade, there's actually not a ton of traffic. And the reason for that is between the depot and the memory on the systems, a lot of this data is actually already cached. If I go to the Vertica management console, you see that I have like 48 queries running right now. All of them are labeled ROS_Vmart. So, when we go and collect data, we know that they're associated with the ROS storage. Okay, and this will run for a little while. Okay, so it looks like it might have completed. So let's go back over here. Yep, so the script completed. Over those 120 seconds, it ran a little bit over 8,000 queries. And again, these are randomized queries from the set of 9. Just going back to the listing over here, essentially for each one of these Vmart queries that ships with the Vmart example, I created a version of it for S3 that points to the S3 based external table, and then a version of it for NFS that points to the NFS exported external table. And other than that, the content of the queries is pretty much identical. So with that, let's try it with NFS and see what that looks like. So now we kicked off the NFS test. If we go back over here, very shortly, we should see 48 queries running. Going back to our FlashBlade, again, there's not a ton of I/O, and that's because a lot of those NFS files have been cached in the host's memory since, NFS can leverage the Linux VFS cache for file data. So even though we're actively accessing all of those NFS files, they're mostly being cached. If I used a much larger database that doesn't fit into the cache, then you could see a lot more activity on the FlashBlade. So this will again run for a while. Okay, so the NFS queries have completed. You see the using NFS and external tables, again, Parquet format, ZSTD compression. I was able to complete a little over 3,000 queries during that minute and a half. And now if I run it on S3, we can go back to the FlashBlade, and you see there's actually a lot more activity on the FlashBlade when you're using S3. The reason for that is there's no Linux caching for S3 access points. That is good in the sense that when S3 is streaming in and you have high throughput, you can get a lot of parallelism with the S3 protocol, so things can go really fast. But if there's actually a lot of data reuse, like there would be if you're issuing, a small set of queries against a large set of data, then being able to use something like NFS for external tables gets you the benefit of memory caching. Over here, if I take a look, I'm kind of peeking out somewhere around a little north of 4 gigabytes a second. It's pretty respectable, over 4 gigs a second using a baby FlashBlade. That's pretty much the smallest we provide. Again, it's very respectable, high throughput. FlashBlade scales linearly, so if you needed significantly more throughput for accessing external tables, you could add additional blades, add additional chassis. So we'll scale up to, I think we've measured and discussed NFS throughput up to about 75 gigabytes a second. We have customers that are regularly running IO against FlashBlade north of like 40, 50, even 60 gigabytes a second for days or weeks at a time. So this is what FlashBlade is capable of when you need to access external tables. Of course, if you are using them in a way that the data can be cached and reused, it's faster coming out of memory than necessarily coming from storage, even when that storage is incredibly fast. So again, if I go back to performance here, look at the last 5 minutes and zoom into that period of time where the query was running, I see I'm getting peaks, again, 4.3 gigabytes a second. So very respectable throughput for a relatively small FlashBlade. Okay, so let's go back to our dashboard, go to our monitor, and we see that with S3 and no RAM caching, we completed, a little bit more than 1,600 queries over that same period of time. So, the main thing I wanted to demonstrate was how easy it is to create, queries that go and access external tables on NFS FlashBlade and S3 on FlashBlade. So this is pretty much what that demonstration is about. So with that, let's wrap up. During this demo, we saw how easy it is to take Vertica database tables, export them to FlashBlade using either S3 or NFS, and then use that exported data to create external tables that you can then query just like you would regular ROS format tables, but have those tables reside on either NFS or S3 with FlashBlade. We saw that there is a difference when you have caching for that protocol like with NFS versus no caching with a protocol like S3. And that's about it. So again, the emphasis is really on exporting to FlashBlade and using FlashBlade to support external tables. The code that I showed off is actually still a work in progress. When it's ready, I'm going to put it on this GitHub repository that we have as part of the Pure Storage Open Connect space. So there's a Vertica repo, and the easiest way to find it is to start with this code.purestorage.com website, then click the database button, and then scroll until you find the Vertica tile, and then click that link, and that'll take you to our GitHub repository. Again, once the code is ready, I'm going to stick it into this repo. Right now, this repo has code associated with Ansible playbooks for setting up Vertica POCs and code associated with using FlashBlade cloning to very rapidly and space efficiently clone large data Vertica databases. So that's what's in there now. I have other demos that are part of Vertica Unify 2021 that demonstrate those other capabilities. This demo is focused on, again, exporting data and external tables. So, you can definitely use FlashBlade as a fast NFS or S3 storage repository, and hope this demo was useful. Thank you for watching.